Okay, so last time we solved applications by algebraic methods. This time we're going to look at applications where we're going to solve them graphically. All right, so again, we're going to solve these using the graphing calculator, so hopefully you have your graphing calculator with you. All right, so the steps are, all right, so remember we have an equal to, which means we have one side of our equation and the other. And so that's basically what we're going to do in the calculator. We're going to take one side of my expression and plug it into the calculator as the first thing I'm going to graph, and then the second side. So an example here is I've got this equation I want to solve. 2x plus 1 equals negative x plus 4. Now this one's simple. I could have solved this one by hand pretty quickly. All right, but we're going to look at an example, and then we'll get into cases where you might want to use this. And so what we do is we take each side. So on the left side, we're going to plug into y1 on the graphing calculator. We're going to graph 2x plus 1. And then on the right side, we're going to graph in y2, the right side of the equation, which is negative x plus 4. All right, you graph those at the same time. So you graph them in the same window. And then what we're going to look for is see if they have a place where they intersect. If they're parallel, that's the identity case. If they're parallel, there's no solution. Right? They never cross, so they don't have any solutions. And if you graph them and they end up being the same line, so the same line graphs twice, that's the infinite limiting case. We're not going to look at the special cases, but that's what happens in the special cases. We're going to look at the case where they have the intersect, right, which our calculator can find it. Right? There's a window on the calculator that allows us to do this and find the place where they intersect. And again, we're looking for the x value. Right, the calculator will give you the x value and the y value. It'll give you the whole point. But the solution we're interested in, right, is what x value solves this. All right, so we don't need the y value. It's just extra information. It's where they're equal. It's what value would come out if I plugged that x value in. But I'm looking for the x value. All right, so some examples. So we're going to do an example. I'm actually going to do an example where we solved it algebraically last time. Do you remember the complex equation where we had fractions, where we were solving 3x minus 1 over 5 minus 2 equaled 2 minus x over 3. Right? We got the solution. It was exactly 43 over 14. All right, we did that on the last one. Well, we can solve this with the calculator. The problem with the calculator is it'll give me the decimal answer, so it won't give me the exact fraction, but it will give me at least the decimal approximation. So what we're going to do in y1, I'm going to input, and be careful when you input the fraction, make sure you do the 3x minus 1 divided by 5, that goes in the calculator, minus 2, it's one side. And then y2 will be the 2 minus x minus 3. You do need to put parentheses around the numerator so it follows order of operations. You need to put parentheses around those. Now I'll pop up my calculator and show that. Oops, that's not my calculator. There's my calculator. Oh, my calculator is not connected. Well, let's see if it'll connect here. Alright, there we go. Alright, so sorry about that. It kind of timed out, I guess. Alright, so we got to go to our y equals. Plug in our first equation. So again, make sure you're careful. Put parentheses, 3x minus 1, divide by 5, and then don't forget the minus 2. Alright, the second equation was, don't forget parentheses, 2 minus x, and parentheses, divide by 3 was the equation. Standard windows look like what I have, so I'm going to go, if you don't have a standard window, you can hit zoom and then select standard. We'll see if I need to adjust my window. See if I can find my point of intersection. And I don't. Okay, so there's the blue line's the first equation, the red line's the second equation, and then how you solve this is what we want to do is, if you look up here at the top, these are all the things I can do on my graph. If you look here, there's this blue word calculate, C-A-L-C. That's what I want to do. I want to calculate stuff on my graph. In order to get to the calculate, I have to hit, because that's the blue part, I have to hit second trace. So I have to hit second first, and then trace, and it'll pop up that window where I can do stuff on the calculator. I want to find where they intersect, so I'm going to select 5. Right, then the calculator asks me to do stuff. I'm on the first curve, which is the blue curve, and I have to move my cursor over as close as I can to that spot. Alright, hit enter. Now, if you'll see, it's highlighted red, so I'm on the red curve. Hit enter. And then it asks you to guess. And you only need to guess if it feels like you need to move it a little bit to get closer. Looks pretty close to me, so I'm just going to go ahead and hit enter. Alright, it should give me the answer, which again, it's the x value. The y value is what they would equal to if I plugged the number in. So if I plugged in that x value, both sides of the equation would give me that ugly y value, negative 0.3. Alright, so the fraction, remember, was 43 over 14. And if you take 43 over 14, it does come out 3.7142, if we round to the 6. And so that is the right answer. Now, again, the downside with the calculator is we don't get this exactly. What the calculator gave us was the approximate answer, 3.0714886. Alright, but if it's an approximate answer, it approximates that numerical value. So that is the downside to the calculator. Alright, I'll do another example where, again, we're going to look at another. Usually we use the calculator method when it's a very complicated expression. And so I'm going to solve the following. I've got the square root of 2 plus x equals 3 times x minus 1. And so the square root of 2 tells me that this is going to be an irrational number already. And again, a lot of times when we have irrational numbers, that throws students off. So I'm going to solve this graphically, right, because it's a messy number. And so again, on the one side, I'm going to plug in the square root of 2 plus x. And in the other part, I'm going to plug 3 times x minus 1. And if you want to distribute the 3, you can. If you don't distribute the 3, do make sure you put parentheses around it. All right, so going back to my, selecting that instead of my calculator. All right, going back to my calculator, I'm going to go hit y equals, clear out what I have in here, and then type in my new equation. So the first one's the square root of 2, so I find my square root key. Which again, where is my square root key? There it is. All right, second, that, square root of 2. Hit over, because x is not under the square root, so then I hit separately plus x. And then this one, remember, was 3 times, parentheses, unless you distribute your 3, x minus 1. I'm going to leave it exactly. All right, I believe a standard window should work, so I'm going to just go ahead and hit graph. If I don't see the point where they intersect, then I have to make my window bigger. So we'll see if it shows up or not. It does, so I'm good. Alright, so there's where my first line and my second line. So remember, hit second, trace. First curve, second curve, guess. So second, trace, there we go. 5. First curve, second curve, guess. As close. Usually I just get close with my cane. I usually hit my button 3 times. So again, I do check to see when I'm on my second curve, if it's there, it is, and then my guess is there. So first curve, second curve, and guess, and so it doesn't end up at a really nice number. So the x value is 2.207, so in the y value, again, I don't need, but that is what, if I plug that number in, that's the y value that would come out. That's the answer that would come out. So the x value, the answer is approximately, since I'm going to have to round, 2.2071. Right? And there's the answer to that equation. Okay, so that's solving equations graphically. And again, if they're complex and ugly functions, a lot of times graphically is the way to go. All right? If you just can't solve it algebraically at all, if you're just running, you're running in circles algebraically, well, you have a graphing tool. You can use it. Right, if you know how to use it, and so solve them graphically. All right, so we'll stop there.